Hello everyone, today we'll show you the latest version of the Chia Bladebit software that allows you to plot using your GPU, and you can still find the new plots using your existing Chia farmer or harvesters. The only thing is the program uses 256 GB of RAM, so I will need to upgrade one of my HP Z840 workstations and install 16 sticks of 32 GB each for a total of 512 GB of RAM and see if I can run two in parallel. I will show you how I did it. The previous version of the software allows you to plot both in memory and on disk, but using your GPU takes it to the next level in terms of speed. Let's see how it compares to the old way of plotting, just using CPUs and SSDs. I think pretty amazing times are coming for Chia. Pretty soon Bladebit will be able to compress plots the same way as GigaHorse currently does it. Let's go over the requirements and different ways of using Bladebit and how to leverage your existing hardware. Let's get into it. Okay, Bladebit Chia Plotter. It's a high-performance K32 only Chia plotter supporting in-RAM and disk-based plotting. This GPU plotter requirements has a minimum, here says memory 256, but in RAM you need 416 gigs of RAM are required to run it, and a few more megabytes for stack space and small allocations. For this base you need a minimum of 4 GB of RAM. So today we're gonna be testing this Bladebit, the latest version of Chia Plotter. Last week we tested GigaHorse GPU plotter, and for the K32 we needed a minimum of 256 GB on RAM, but with partially on RAM we did with 128 GB. That's what we used on an HP Z840. With compression. This is with compression, and the Bladebit, the current version, does not support compression, so we'll try this today and see how they compare. About a few days ago I found this post on Reddit about Chia, which is releasing an alpha build of Bladebit CUDA into the beta program. Chia is releasing an alpha build of Bladebit CUDA into the beta program. With this release, we are looking to test interoperability and compatibility on a broad range of GPU and platform configurations. Phase 1 is GPU plotting now. It's available. That's what we're going to be using today. With current plot format, you can farm these plots with the current Chia client immediately today. So we can actually farm the plots immediately today with the client we have. In phase 2, compression within 3 to 5 weeks. Test compressed plots and simulated farming, so the farmers can understand the compute and power overhead for the actual systems using compressed plots. So that's coming next. And phase 3 says farming 4 to 6 weeks, real farming and harvesting of compressed plots. So still a few weeks out, but let's test. We're in phase 1 right now. Let's test GPU plotting using Bladebit, and then let's see if the farmer recognizes the plots and how long it takes to create a plot too. Let's go and do that. Okay, I have a farmer here and a harvester, and I be upgrading this HP Z840, which currently has 64 GB of memory. I'm gonna be upgrading it to 512. I just ordered and I received 16. Let's see, 16 32 GB each of these sticks. It says here is DDR4. Each one has 16 GB. So I can show you the specifications, but we're gonna be putting this 16 here. We have 16, 8, and 8. So 16 we're gonna be putting here in the HP Z40 and agreeing to 512, so we can test Bladebit. You can see I got it to open now. I got my 3060 Ti here. Have quite a number of M2. These are like PCI SSD drives there, and you have here the two CPUs. They're super dusty. We're gonna have to clean all this up. And you see I have my old memory sticks there. 1, 2, 3, 4, 5, 6, 7, 8. So each one has 8 GB. So 8 times 8, so 64 I have in this machine, and we're gonna be putting this 32, so 16 slots totally of 32, so that's a total of 512. So let's clean this machine up and do that. All right, all clean, looks brand new now. So we're gonna be replacing all these 8 GB DDR4s with this 16 32 GB DDR4. All right, 16 32 GB sticks have been installed of DDR4. You can see 4 here, 4 here, 4 here, 4 here, 16. So we got a total of 512 gigabytes in this HP Z840. So let's put the cover back on. Let's turn it on and let's continue. Okay, with all the memory installed, let's go to the task manager here. You can see all the CPUs right there, and then here memory. You see 512 now gigabytes has been installed. It says here in use and available for 82 gigabytes. Speed 2133 megahertz. 16 slots used. So they all have, each one has 32 gigabytes. So we are good in terms of hardware to test the in-RAM process of creating a plot, Chia plot using Bladebit. Okay, and the alpha binaries from the latest version is here. https://downloads.chia.net/Bladebit. So let's go ahead and click. That's for CentOS, this is for Ubuntu, and this is the Windows version. Go ahead and download the Bladebit and score CUDA.exe. There, downloading. Okay, and here's the file that I just downloaded, Bladebit and score CUDA .executable exe. So what I'm gonna do now is I'm gonna open a git bash here. This is the terminal I'm gonna be using. If you don't have this program, this software, you can download it here at git-scm.com. You can get it, and you can use this terminal, which is pretty convenient. And what I'm gonna do first is let's execute Bladebit /Bladebit and score CUDA.exe -h for help. And let's take a look at. Oh, I think I got a big position here. One less. There we are. All right, so this is the help, the list of commands. If you can see, CUDA plot is needed to create a plot by using the CUDA capable GPU. So we're gonna be trying that option first, which is to use our GPU to create the plots. Then we have the option of doing this plot, create a plot by making use of our disks, and then RAM plot is completely in RAM, and each one has specific requirements. So let's go back here. So you can see here GPU CUDA plotter requirements. OS, Windows or Linux. Memory 256 gigabytes of system DRAM. We have 512 on this computer now, so we're good there. We have double GPUs, NVIDIA GPUs with CUDA capability 5.2 and up with at least 8 gigabytes of VRAM. So we need 8 gigs in the GPU. Now I have a 3060 Ti here. But before doing this first option, go ahead and update to the latest driver. Otherwise, it could give you an error. So update to the latest. I have my NVIDIA here. G4 Experience. All right, I already downloaded and updated my latest one. But go ahead and update your latest. Say game's ready. I'm using 528.49, released in February 8, 2023. That's the latest. All right, let's start with the first plot command. So we're gonna open Notepad, and then what we're gonna use is here. I'm gonna copy from the in-RAM portable plots. I'm gonna copy this command structure here. There I'm gonna type GPU. I'm gonna paste that, and then I know I'm gonna need the farmer key, which is the -f parameter there, -f. and then -C is the pool contract address. That's there, -C. That's the way if you're plotting on a pool, you're gonna need that. And then here says RAM plot, which is the command for plotting on RAM, but we're gonna be using CUDA plot, so we're gonna be replacing this and then just putting it there. Yes. All right, that's the CUDA plot. Now for RAM, a complete plot in RAM, we're gonna just use this. All right, this is RAM plot. All right, and for disk, we're gonna copy this base for portable plot, so we're gonna use this. All right, then we have a basic structure of 3 types of plotting: GPU, RAM, and disk. We're gonna start with the first one, GPU. Okay, the latest Bladebit is actually Bladebit _ CUDA.exe. So I'm gonna replace Bladebit / Bladebit. That's where I have it, Bladebit _ CUDA.exe. So I'm gonna do replacing that from the old Bladebit command. So replacing the 3 of them. There we're okay. So we're good there. Now the second parameter we're gonna use is -n, which is the number of plots. I'm gonna be plotting 2 on each. So -n 2 -n 2. Okay, and now we gotta get the farmer public key and the pool contract address. Let's go again and get those. Okay, farmer key, replace that. Farmer key, replace that. Farmer key, I'm gonna replace that. Now I need to get the pool contract address. Okay, I'm gonna replace the pool contract address there. So I'm using space pool. There it is. Okay, and now we're gonna, in the first command is CUDA plot, the second one is RAM plot, and the third one is disk plot. For the output directory, I'm gonna be using my G file, G drive, just G colon. For RAM, I'm gonna be using the same G colon. And then for this plot, we're gonna be using a temporary directory. So in this case, it's an SSD file, or drive, I'm sorry, F, and output G. I'm gonna go ahead and save this so I have it. So this is CUDA Bladebit CUDA commands. All right, let's go ahead and execute the first one. So for GPU, I'm gonna be copying all this, and we're gonna plot 2. We're gonna create 2 plots using our GPU, and we're gonna see how it goes. Let's go back to the terminal here, right click, paste, enter. All right, there we are. We're starting plotting using my NVIDIA GeForce RTX 3070. The thread count, I have 24, 2 CPUs with 12 each, 34. Let's see, CUDA compute capability 8.6. All right, max blocks per segment, we have 16. Let's see what else. Total 8 gigs, so free 6.97. And here's the allocating buffers right now. Require RAM 84 gigabytes. Intermediate RAM required 2.79. Host RAM required 156. Total host RAM required 240. That's what's needed. 240.92. And then it says GPU RAM required 5.71. So now, right now it's allocating buffers. Let's wait and let's see how long it takes to create our first plot. All right, when the plot is being created, let's take a look at the performance. CPU is being used, but not much. My computer is at 10% average. Let's take a look at the actual memory. Okay, memory, we are around 52%. So yeah, it used pretty much half of the 512. You can see here 512, and we're at 52% usage. All right, and let's look at the GPU. We are at 40, 30, so it's fluctuating 42%. So 7.38 here you can see. So yeah, so you know we are using some GPU and half of the available RAM out of the 512. All right, first plot's been completed. Completed plot 1 in 386, so that's 6.44 minutes. So amazing time for one plot. Let's go ahead and run the second plot here. It's running. We'll see if there's any difference. I don't want to use too much of the GPU, but that was a pretty good time. Okay, and the second plot just completed in 6.34 minutes. So that's 10 seconds less than the first one, 6.44 versus 6.34. A little bit better the second one. That's a good test, an amazing time with a 3060 Ti. Okay, let's do another test. Let's see if we can run two in parallel now. So I'm gonna copy first command here, enter. I don't need this, so I'm gonna call it GPU1, GPU2, and then I'm gonna be using another destination, which is F. So G and F are the final destination. Both are CUDA plots, so both using the GPU. Let's see if it works. So let's start with the first one. Let's kick off the first one here. Go to, I have two Git bash windows, right click, paste. All right, let's kick off the first one. All right, allocating buffers. So the first one is going. Let's see. Let's copy the second one, GPU2. Before doing that, let's check the performance metrics. So CPU not much, 8%. Okay, let's see memory. We are about 5%, not much yet. Let's see GPU. Not much yet. 14%. So not much yet. All right, now memory really ramp up. So we are at 265 out of 512, 52% is being used. So I'm not sure if this is gonna be enough. 512. So you can see here memory spiked here, and now we're at 52%. Plus the applications I have it open, currently open, so that takes memory as well. Let's see in terms of GPU, we're at 50%, right in the middle. 50% being used. Utilization here you see 55, 46, so it's fluctuating. So let's go ahead and run the test anyway and see what we get. All right, so I'm gonna go to the second line. You can see the plot is going there. Let's copy this GPU2. Let's go here, right click, paste, enter. All right, second one is running, so it's allocating the buffers. We gotta wait for a few minutes here and see if we can get it to run concurrently. And you can see, you know, it really slowed down the time, so it's not worth it to run both in parallel. I think it's worth to run just one. So 512 is not enough to run both in parallel. All right, one more thing. After you plot in the new hard drive and destination, you gotta go to users, your user Chia mainnet config, and then once you see the config YAML file, just double click there and make sure you add your new destination folder there. You can see I have all my destinations in this harvester, so you're gonna have to add it here, dash and the letter of the drive there and the folder, specific folder. It's gonna refresh. It's gonna take a few seconds and then it's gonna refresh. You can also add it from the GUI. Plots, add plot directory. So you can add it here from the GUI. All right, I think that we proved what we wanted to, which is to run Bladebit using GPU-based technology, and it worked. We got the plot down to 6.34 minutes using a 3060 Ti. Uses roughly 256 gigabytes of RAM, so quite a few gigabytes of RAM needed. But compared to GigaHorse last week, we did a similar test. It took about 7 minutes. It does require less, 128 gigabytes of RAM, although it can provide compression, which Bladebit currently doesn't. So we're gonna have to wait for the next phase on Bladebit and see how the compression plays into the overall equation. But I think so far I'm really happy with Bladebit, and if you have the available memory, right? If not, it's probably not worth it. But if you have available memory, it's good to run Bladebit and just keep farming on your existing farmer or harvesters versus GigaHorse, which you will need to install the GigaHorse farmer or harvester. All right, hope you guys enjoyed the video. Let me know if you have any questions. See if I can post an update as soon as I know more about the compression on Bladebit. Thank you so much, and see you in the next video.